Hello, ladies and gentlemen. Good morning. My name is Samuel. I'm from UCSI University, and today we're going to look at the topic AI in airports. Are we safe enough? So, before we begin, I'd like to give some statistics on the current situation that we have in the world. So, on an average in a day, there's 2.6 million people that use the aviation services like the airplane, and then there's 4.9 million baggages that goes through the airport every day. Out of this 4.9 million, there's about 3,656 anomaly objects that are detected in these baggages. And in the year 2022, it's projected that it's going to be a 7% increase in this number of anomaly. And usually, the officer is 50% of the time tired and 50% of the time doesn't give accurate predictions. Moving on, we want to actually help develop a convolutional network that will help us detect this strange object in the baggage. We also analyze the key effects of the parameters of this trained framework, and we also want to investigate the accuracy of the developed framework. So we're going to look at what CNN. CNN is developed by Yan Lincoln, a French scientist, and CNN has several layers. We have the input layer, hidden layer, and then an output layer. And CNN is best optimized for image-related tasks. For example, the image below, we want to classify an input images based on whether a car, truck, or van. You can see CNN is actually able to help us identify if it's a car, truck, or van. So invariably, CNN can help us in object detection in baggage systems. So we want to use yellow V5. That is the CNN we want to use. Why, you may ask, yellow V5? Because yellow V5 is a single stage of the detector, and it also has an activation function of ReLU and sigmoid, and the optimization function that it uses is SGD and Adam, and the cost or loss function is BCELL or FL. The head, backbone, and neck is using the current latest technology in the world. So we want to detect these items in our baggage. We want to detect the gun, bullet, knife, wrench, pliers, power bank, ballon, lighter, sprayer, hammer, scissors, and handcuffs in our baggages. So in our data set, we have 47,000 images that we want to train our model with. Now, before we begin, we have to optimize our hyperparameters. So we'll optimize all these parameters before we build our model. So after training our models, we get the accuracy and precision. You can see in curve A, our precision is about 94.8%, and then our recall actually goes down to zero point 0.0, which is actually very, very good. Because in the normal circumstance, we want to get a recall that is very low. Recall is the number of times predicting wrongly, and you can see our confidence score is having a perfect bell curve, and the precision and recall is having a perfect curve also. Moving on, our conversion matrix is doing exceptionally well. You can see it's able to predict everything accurately well, and it's doing amazingly well. Now, this is the training and validation results. You can see our loss for box objectness and classification is going now approaching 0.01, which is exceptionally good, and our position is going up to 90%, and the recall is about following it of about 82% thereabout. And then we also have our MAP at zero point 0.5 to be 90%. That is really, really good. And MAP at 0.5, 0.95, about 70%. Now again, we're going to come up with a table to see the precision and recall and accuracy of the individual classes. You can see our model is able to predict everything accurately well, with the exception of GAN, which is 83.5%, which is because of the number of classes, number of images in the class of GAN. Now you can see this is a sample of the images that we got from trainer model, and we compare our model with Yellow V3 and OneNet SSD V2, and you can see Yellow V5 still stands out accurately fine with the MAP of with the MAP at 0.5 of 90% and the precision of 90.4, which is very good than OneNet SSD and Yellow V3. Our model was performed and tried in a real time, and then we got exceptional results, and then a speed of 0.5 millisecond and a pre-processing speed of 97.8 milliseconds, which is absolutely good. Thank you so much for listening. And to add on, this project actually contributes to sustainable development goals, which is a very good thing. Thank you so much.